Moderating today's panel on how will blockchain change business is Nicholas Thompson, Editor-in-Chief of Wired Magazine. So let's get to it. Nicholas, the floor is all yours.
Great. Thank you very much. I'm Nick Thompson. We have an amazing panel here. I'll go through everybody, and then we're going to start asking questions and arguing. So this is Ramesh Gopinath. He is the VP of Blockchain Solutions at IBM. IBM is doing all kinds of crazy blockchain work, including in the media industry. Just yesterday, they announced a partnership on advertising, which seems super interesting. Then we have Johal. He's the CEO and founder of Agralogics. We have Joe Lubin. He is the founder and CEO of ConsenSys. He also helped create Ethereum, one of the most important blockchain platforms, and Ether, a blockchain currency, which I assume you all own. And then we have Ciamac Moallemi. He is associate professor in decision risk and operations at the GSB at Columbia. All right. We have 3 goals, or I have 3 goals for this panel. Number 1 is to make everybody understand blockchain a little bit better. If on a scale of 1 to 10, your understanding is a 2, we want it to be 4 at the end of the panel. If it's 4, we want it to be 6. Second, to explain what businesses will change and which businesses will not. Right? Everybody kind of thinks blockchain will be super transformational, most transformational thing since the internet, or they think it will be like Esperanto, it won't be anything. But what will really happen is some things will change a lot, some things will change a little. So if we can get closer to that. And then my third goal is to not let the panel devolve into picayune arguments about stuff that nobody understands, which I think we're not going to have happen because we have awesome panelists, and I've been talking to them in the green room, and they are great. So let's get going. What I want to do to start is the convention we do at Wired Magazine, which is where we explain things at different levels. Explain it to a child, explain it to a high school student, explain it to a graduate student, and explain it to a professional. So Ramesh drew the short straw, or maybe the long straw, I don't know. And we're going to start, we're going to run down the line. So explain blockchain like you're talking to a 6-year-old.
Oh boy, OK. So blockchain is about trust in business transactions. So I need to tell a kid, and explain it to a kid. And I think the simplest way to think about it is think about half a dozen kids playing a game of trading marbles. Right? Each of them is in their own room at home, and basically they have a board in which they're writing down transactions. I trade a blue marble for a green marble. A and B do that. C is not part of the transaction. Okay? So that sort of trading of marbles, if they could all do, follow a protocol so that everybody, and the protocol is by making phone calls perhaps, each in their own home. And they're in the bedroom, they have this nice board in which they write down transactions in indelible ink, okay? So you can't erase things. And you want to have that exchange, conversation such that at the end of that, each round of conversation, everybody agrees that A has decided to give B a blue marble in exchange for a red one. And all of them in their bedrooms, in the chalkboard, have that information. Everybody is in the same state. So effectively what happens is, across these kids trading marbles, there's a single version of the truth that they arrive at. That is the essential idea behind blockchain. Trusted data in interactions between multiple parties by following a certain protocol.
My kids literally had a fight about trading marbles not that long ago, so I will hire you to come babysit after the panel. All right, Sumer, you want to take a high school student?
Sure. So I have a 15-year-old son who's actually in high school, so this is how I explain it to him. So he's really into cars, and just passed his driver's license test and trying to get into driving. And so, we were thinking about what car to buy, and so I said, well, how can you trust what you buy? Do you really know what the car is? Where's it been? Because we're looking to buy a used car. What is its performance? Not just what the seller is saying, but what maybe previous sellers, what do manufacturers say? There's multiple stakeholders. How do you arrive at a trusted decision point on which car to buy? And then how do you contribute to the person who's going to buy it from you? That same thing. So a shared, sort of ledger of information where different people who have interacted with the car, whether they be regulators, mechanics, owners, other types of folks, can all contribute to, in a transparent but permissioned way, so you can only access if you have permission, so that you can trust the information. That's how I'd explain it to my 15-year-old.
You're a good dad if you're letting your 15-year-old buy cars.
We'll see about that.
Joe, graduate student.
Yeah, we like to think of blockchain systems as a next generation database technology. Essentially, the economist described it as the trust machine. It's going to bring in a world where instead of building siloed information systems on old database technology, we'll be able to build shared infrastructure. That trustworthy, that trustful quality comes from the fact that many different nodes are kept, in the case of Ethereum, tens of thousands of nodes are kept virtually perfectly in sync by something called a consensus algorithm. The consensus algorithm involves something called crypto economics. One entity does a bunch of work in order to win a contest so that that entity can get paid for advancing the state of the system, proposing the next state. And crypto economics also incentivizes all of the other nodes on the system to follow in behind that first leader of consensus, and therefore they are much more likely to get paid at some point in the future. So the system enables us, whether we're competing already and want to cooperate, or in other sorts of collaborative situations, to be certain that nobody can cheat the system. Even up to half of the actors on the system are malicious.
Wow. Okay. Ciamac, you want to take on how to, I don't know, talk to an investor who invests in blockchain companies?
Yeah, so my perspective is not so much to dive into the technological details in terms of the crypto or networking or so on, but my background is coming from operational and economics kind of background, and to view these kinds of blockchains as a novel kind of economic system where actors can interact in a platform in different ways. On the one hand, you have users, people who want to maintain balances in a ledger or execute a smart contract or accomplish whatever kind of need they have. On the other hand, you have these service providers, these validators, who are sort of checking these contracts and balances and making sure everything is kosher. And the traditional economic model is that you have users on one side, but typically the other side is a single centralized provider, a monopoly, if you will. Right? And the downside of that is, we know that monopolies can do all kinds of bad things, like extracting monopoly rents. Things like blockchain provides a mechanism where you can have sort of a platform on both sides where you have sort of competition, but without any kind of a centralized entity that can extract a lot of power. So I think the exciting thing there is to enable, through technology, economic models that aren't possible in traditional systems.
All right. I feel like I am a centralized entity.
Smart contract a bunch today. We should probably define that. So
do it.
Smart contract isn't smart, and it's probably usually not a contract. It's just a program that runs on a blockchain system.
Yeah, and I think I'd just like to clarify one more thing, is a lot of these questions about what blockchain is, with all due respect, sort of are almost irrelevant. Not saying one shouldn't be curious, but it's sort of like asking, well, what is the internet? Well, really, who cares, right? How do we use the internet that matters? And there's so many different ways of using it, so many different configurations. Really, nobody cares about, most people don't care about what HTTP stands for, or what it does. And what people really care about is how we collaborate through and various things that you do. And there's so many different use cases of the internet. So I think blockchain is very similar to that, and one should focus on the use cases, and hopefully we'll do that.
By the way, speaking of use cases for the internet, you all are allowed to ask me questions. They will go through the internet to my iPad. I will then ask those questions. So fire away. I think you all know the instructions. All right, I want to get into what blockchain will change and what it will not. Why don't I start by asking Joe? You, a couple years ago, decided that this would be huge before everybody decided it would be huge. So how did you see its potential, and why did you start Ethereum?
Yeah, so following on your point, there are many different use cases for this technology. There are enterprise use cases, government use cases. We do a lot of that work around the world. But the really exciting aspect to us of the technology is the public blockchain. We think of the public blockchain as the next iteration of the World Wide Web. So you in the audience will never need to use blockchain. You'll just keep using the World Wide Web. And you won't need to, as you indicated, understand what the latest iteration of the plumbing is of the World Wide Web. So we're currently in a Web 2.0 world where we have siloed systems, walled gardens. The internet's kind of broken in many different ways. In a security context, it's broken because identity's broken. We haven't really figured out identity very well. So the Web 3.0 world, or the decentralized World Wide Web, looks like trusted transactions, automated agreements, and smart software objects on a public blockchain like Ethereum. But it's other protocols as well. It's decentralized storage, it's decentralized bandwidth, and decentralized heavy compute protocols. So instead of using applications that are client-server in their architecture, where Facebook or Google or some other entity is providing you your interface and providing the back end will be in the form of these smart contracts on something like Ethereum. The front end can be distributed to you in a decentralized way, or it can come in through a server. The way that we currently interact with applications on the internet is essentially by spraying aspects of our identity throughout the internet, having them stored on corporate servers, monetized by corporations, and not adequately secured often by those corporations. We're building many different core components like identity, self-sovereign identity, which you can establish for yourself as the root of your identity. You can encrypt aspects of your identity and selectively disclose those in situations you designate. You can monetize those if you want to. We can link that in. We can use it as single sign-on. We can link that into legacy identity providers like governments and your bank manager. They can attest to something about your identity. And the decentralized World Wide Web will enable us to change the nature of business, where instead of a company offering services to consumers in a somewhat adversarial context, we are building in many different niches right now protocol-based open platforms that are multi-sided markets where lots of different actors can perform different roles from their identity construct, merge a set of services where you ideally won't have a single entity that's overly controlling or overly monetizing.
So Ethereum is going to be running in the background of all of these things inside of the web. We'll be using it. We won't even know we're using Ethereum. Tell us some simple, specific thing that somebody in this room has done using Ethereum where they haven't realized it. Or give some specific example of something simple that people in this room will use in the next 5 years on the blockchain where they won't realize it's the blockchain.
So the technology is still immature. There are many different use cases. There are literally hundreds that people are working on that are small components. In Zug in Switzerland, citizens are the systems just moving into production. Systems are going to be able to establish their own blockchain-based identity, go into the authorities, validate that, get an attestation from the government, and then access government services and vote in plebiscites. Another one is an adjacent music industry platform where we have about 100 artists testing it out, including 2 Grammy Award winners. They're uploading their identities, they're creating band pages, they're uploading their content, they're attaching usage policies in the form of legally enforceable documents, and consumers are able to acquire those licenses in real time, pay the artists in real time, the payments can get distributed in real time, and essentially in that situation, the content creator is accessing the consumer directly, and the intermediary, which usually extracts about 70% of the value, is participating much less in that transaction.
All right, Ramesh, let me ask you a variation of the question I asked Joe. IBM has clearly decided to go hard into blockchain. IBM is pivoting to blockchain. I hope that you crush IBM's AI unit. No, I love IBM's AI unit. It's funny.
Good competition is always a good thing.
I know. When will you beat the AI unit? But when did IBM decide, wait a second, let's do this blockchain thing. Let's go hard. Let's hire a ton of people. And why did they make that decision? What did they see?
So the decision was made in 2015, and I had the dubious distinction of presenting to the CEO and the senior leadership about here's a new technology that has tremendous potential. Especially, I was looking at the supply chain space as an area where this could make a huge difference. And the reason why we decided to go big on it is very simple. For us, a blockchain is a trusted way of sharing information and business processes, or trusted data and trusted business processes for multi-party interactions. When I say multi-party, every business interaction is a multi-party interaction at the end of the day, right? So that is a sweet spot for blockchain. Why? Because all of those parties have a single version of the truth. I'll give you a few examples very shortly. So that basically meant for us that this is going to transform every industry eventually. It's in early days of a new technology. All that is true. It'll take time. There are many variations of the technologies. There's Ethereum, there's Hyperledger, there's Corda, there's this, that, and the other thing. All of that, to me, is noise that will eventually settle down at some point in the future. What we were excited about is what could we do with this thing? So the kind of things that we thought we could do was very simple. One, I walk into a store and want to buy something. Is that food safe to eat? The answer to that question depends on many actors in the supply chain, all the way from farm to the store, having exchanged some information that allows me to know what happened with the food item, just like the car example that was mentioned earlier, right? That requires a trusted information across these participants, and also a trusted workflow, if you want to call it that, which is what a smart contract also at the end of the day is. That is an important problem to look at. Another example, we're all citizens, and we would love for our healthcare data to be sort of shared only with our consent. Wouldn't that be wonderful? That's not what happens today. The health ecosystem, just like the food ecosystem, if they use a blockchain, that could dramatically change things. So we really looked at what are all the sort of business use cases where exchange of information happens and there is friction because of trust or what have you. If we can get a trusted database where these companies could share information and share business workflows, that could dramatically change. And I think that's pretty much every industry in my view. So this is going to affect pretty much everything we can think of. The real technology at the end of the day, which sort of wins, is somewhat secondary to me. We believe at IBM that there's tremendous potential for this capability, and it's all about the business use cases we build on top.
And Sumer, you believe entirely that supply chains will be changed dramatically, right?
That's right. So our company, Agralogics, has a data platform specifically for food and agriculture enterprises. So we connect their supply chains with their data. And as Ramesh was mentioning, one of the big issues with food and ag companies is not only the food safety issues, which is a consumer looking in, but sort of there are literally hundreds of use cases within a food enterprise, from the way they manage their compliance, for example. And there are dozens of regulatory compliance things. In California, for example, there's groundwater compliance that you have to make sure the groundwater is not depleted as you're watering your fields. The trust aspect of that and the reporting of that is really under scrutiny because nobody wants to really report how much water they're pumping, right? And to good reason, because once you lose your water rights, you're dead as a farmer. So there are a lot of trust issues like that on compliance. Then there are issues with payments. So, you mentioned smart contracts. We see our customers struggling with, a $1 billion food company will basically have $500 million or more of payments going through the season to its growers, to its input providers, and there are literally tens of thousands of payments that are made that are not synchronized and have fees that could be reduced by, 20, 30, 40, 50%. So just in those two areas, payments and in terms of compliance, we see just massive opportunity to improve the efficiency of the supply chain. And I think that's typically what we see from being inside enterprises, and these enterprises wanting to do something with blockchain but not having a clue on how to do it, and it's so new.
So if I'm hearing you correctly, the area where blockchain will be most disruptive most quickly is areas where trust is most at a premium, where there needs to be more trust and where a system can be implemented that adds that.
That's right. And as Ramesh was pointing out, from US elections to banking to the written word, the written word was invented to essentially make sure that there was a trust between two parties. There are historical institutions in place to enable that trust. But what is happening, and I think to your point, is that the internet age has really seen a public erosion of that trust. The institutional, the big shift here, blockchain is just the enabler. The big shift is, as a society, trust is shifting. And when trust shifts, then people are looking for various ways to manage and get that feeling. And that's where these techniques can be tremendously helpful.
Yeah. I'm in the media. I don't know anything about the erosion of trust. Yes.
Yeah, so
Exactly.
so let's have a show of hands. How many people buy organic food?
Right.
Do you know that today in this world, more organic food is sold than is produced? That's a trust problem. It's very simple for me, at least, the way I think about it. There are basic issues like that that can only be solved by entities who are in that, who are involved in that business, if you will, share information. And today they wouldn't share information. Why wouldn't they share information? Because for this sort of information sharing to happen in the food supply chain, you need a place where competitors have to be in. Like, for example, a food supply chain solution has to involve all the big retailers, the Krogers, the Walmarts, the Unilevers, the Nestle's, the suppliers, and so all the way to the farm. Why would they share data in a database unless they are completely confident that they can share it and it's selectively visible and they're not giving up business secrets? Yep. That's where blockchain comes in. So that's why, for us, trusted data, trusted business process, once you establish that, you can start doing all these interesting things on it.
All right, let's pour some cold water in this organic food, because I know it's all about trust, but like, you read about blockchain, you read about Bitcoin, it's all about stuff getting stolen. Come on. So let's go to Ciamac. You have some questions about whether blockchain will actually transform everything and whether next year we will all have blockchain certified organic food and blockchain certified name tags.
Right. So, I mean, on the one hand, I'm optimistic and I'm excited because, as I was saying earlier, I think there's a potential to move from, sort of centralized economic models to decentralized economic models. But the thing that gives me a little bit of pause is that you have to realize that this comes at a cost, right? Decentralization is necessarily much more complicated from a technological perspective. That's why, we have this, we even have to sit here and try to explain in simple terms how this stuff works. And moreover, there are huge costs in terms of efficiency, right? It's typically much more efficient to do things in a centralized way. And I think a poster child for the type of inefficiency one sees in blockchains, and this is, I will point out, an extreme case, and there might be better ways to do things, but is if you look at Bitcoin. Right? Bitcoin is at its heart, a payment system. It's a mechanism that keeps track of balances, and one person can pay another. You might contrast that with more conventional payment systems like PayPal or Fedwire or kind of something like that. And let's consider Bitcoin. Bitcoin has this nice thing that it's decentralized, right? You don't have to trust anybody. On the other hand, it's extremely inefficient. It processes 3 transactions per second. Visa processes 30,000 transactions per second. How much does it cost to run the system which processes 3 transactions per second? Well, the revenue that's paid to the validators in Bitcoin that operate the system, tens of millions of dollars per day. So literally tens of millions of dollars per day to run 3 transactions per second, which is something you could do on an iPhone. Right? So there's kind of an enormous cost, and you get something for that. You've moved to this decentralized model. You don't have to trust anyone, but you have to ask yourself, is trust, is that lack of trust worth it? Because there's other mechanisms for trust. For example, the rule of law. Right? So let me give an alternative in the case of organic food. What if the FDA set up a database where everybody had to report, the provenance of the food and where it came from and so on and so forth? And I'm not an expert in the food supply chain. There might be a whole bunch of issues with that, but that is an alternative, right? So you have to compare, I think, the centralized and decentralized alternatives because in many arenas there are other mechanisms for trust available, and I think that's going to define the business areas where the blockchain becomes very important.
Yeah. I would agree.
Hold on, Sumer, I want you to take that, but I want you to start because 3 people in the audience have asked the question, why does blockchain ensure trust? So I want you to, in response, explain the case for why blockchain is more trustworthy, and then we can go back into whether centralized is more trustworthy or decentralized is more trustworthy. So what is the case for why blockchain is more trustworthy, and then defend the food?
Sure. So again, from my and our company's perspective, the reason why we see it to be more trustworthy is because there's a multi-party consensus of the single version of truth. So one party doesn't control what actually happened. As an example, in the food chain, everybody thinks, well, why aren't these companies posting what's actually going on? There are literally, hundreds, if not thousands of people collaborating on one piece of land to make some food happen. And everybody's version of truth is slightly different. And so if all parties knew what was happening, and it has implications not just in trust for the consumer, it has implications on trust for the company itself. So for example, there's a regulation that when you spray a chemical on a field, because this is not for the organic people over here, but this is actually done for most of the food in the world, that you are not able to walk, or you're not supposed to walk onto the field to do other things because there's chemical there. Well, that gets violated all the time because there's no multiple sort of a distributed ledger where everybody can see what is actually going on that field.
But so how do you make a transaction so that it is shown that the chemical is sprayed on the field, and how do you get that onto a distributed ledger that everybody can check?
So that's where the tooling comes in. Just with the internet, there were a bunch of toolings called the browser, called your email client, just to name a few. A lot of tooling that sort of makes using of the internet easier and sort of seamless. There is tooling that is going to emerge, and multiple companies, I feel, we are one of them, are going to build that tooling to allow that collaboration in a permissioned, transparent, and sort of commonly shared manner within an enterprise, such that when and as that enterprise has to collaborate with outside supply chains and their blockchains, they can actually be enabled to do so.
All right, so you're going to create some tool so that the pesticide manufacturer and the farmer who's spraying the apples actually communicate, and then you're going to get it onto the distributed ledger. But how do you make it so that the farmer and the pesticide guy don't just collaborate and put a false transaction, which is then put on your distributed ledger?
Because everybody has to agree that that's what happened, and the transactions are immutable. They don't go away. So essentially, you
right, but if you put a lie,
you could have collusion amongst a small set of actors.
Right.
If they prepare for it, but if you're putting data on the network in real time, it's much harder to cheat that stuff.
That's right.
Yeah, and also I think blockchain is not a panacea for all trust. Let's be clear. I think it is a trusted database, and we have some principles that make it trusted. I'll mention that in a second. But the critical thing is things can happen outside the blockchain. Imagine I have a blockchain, the example you gave is also a good one, right? The example I usually give is we have blockchains for also container shipping. There's a project that we are doing. Now, if there is this guy who's exporting avocados from Mombasa to Rotterdam, and he decides that basically he wants to bribe the customs officer to get a signature, and then the customs officer sends the approval transaction to the blockchain, guess what? Something bad happened. The blockchain doesn't know anything about it, right? So you got to understand, but nevertheless, with a blockchain and what you put in there, you can significantly make it harder. It's a quantum leap from where we are today, but that does not mean that nothing bad can happen.
Right. Garbage in definitely will result in garbage out, but just like surveillance cameras improves overall the security of a thing because people see that they're being actually, looked at. Similarly, I think when transactions that people do become ubiquitously available to the entire enterprise, the incentives for cheating reduce. That doesn't mean it'll be flawless.
So let me give 3 reasons why blockchains are trusted. And notice I'm not using things like centralized, decentralized. All of that is a red herring in my view. It's totally irrelevant to what is going on here. One, every transaction is digitally signed by the party. So I can't say I didn't do that. Non-repudiation, right? That's the first principle. The second principle is when transactions are put in there, multiple parties can endorse or vet the transaction. Simple example, I deliver something, FedEx delivers something at destination. You can't have, I didn't deliver that, or there was right? Because if 2 parties, just like we signed, remember? All of us, when you get a package, we sign off. So multiple parties endorse before a transaction goes in. The third piece is all of the parties who keep managing the data, there are multiple parties managing the database, and they're all independent entities in some sense. So I can't go about changing things in my database, right? So transactions got in. Once it got in, it is safe, and basically it lasts forever in some sense. That's essentially the idea behind the trust. And the final point on trust is code itself can also be stuck like data on the blockchain. And guess what? You get trusted business process, because every business process, after all, some logic that's running between companies. So it's that simple. Now, the rest of it is crypto detail to ensure it happens, the right, decentralization, all that stuff is somewhat tangential to the main point in my view. And I also wanted to make one quick distinction because, since you mentioned earlier that there is this notion of decentralization, multiple parties and all that. I just want to make it very clear. At the end of the day, you have a database, and you have people who are transacting. That's simple. Those who run the database, if they're all known parties, if something goes wrong, what do? You fall back on the legal system. That's not going to go away. Don't expect technology to solve everything, right? In the case where those who run the database and send transactions to it are completely anonymous, thank you, Bitcoin, then you have to worry about all these economic incentives. But the permissioned databases that we're running for food trust or global trade digitization or healthcare and many, many, many. We have 400 plus projects we have done in this space. None of them require any of these cryptocurrency type stuff. None of them have to deal with issues that you mentioned. So we got to think about this in terms of either you say it's a simple database of a new kind that gives trust, or you say, I'm going for decentralization. It's a choice, and we have made our choice. It's about business use cases.
So that's a good case, that there's a lot of trust that can come with blockchain. I can prove that not all blockchain things are trustworthy, because the initial creator of blockchain, Satoshi Nakamoto, nobody knows who he is. And yet I, as editor of Wired Magazine, every month get somebody calling me up saying they're Satoshi Nakamoto. So not completely trustworthy. It's one of the burdens of my job. All right, Ciamac, you've had your eyebrow arched for the last 7 minutes. Please respond to what you've just heard.
So, I think that's a fair point. I think if you look at some of these so-called private blockchains, which are meant for use by a group of people, perhaps a consortium of banks, a consortium of people in a food supply chain, who are already known to each other, who already trust each other, who already have the fallback of the legal system, then something these sort of blockchains which are both private and permissioned, it becomes something like just a fancy database, a database where multiple people can sort of use it at once, right? So I think that's fine, and it's actually not that big a leap beyond traditional database technology. I think where you get a bigger leap, and where I sort of have more concerns, is where you try to go to this kind of a decentralized system, where things like Bitcoin and Ethereum, where you want to operate without any kind of trust, and you want to be able to operate in the absence of a legal system. And the challenge there is the way you get trust there is you get it works by having many people check the same transactions, right? So Joe said that in the Ethereum network you have tens of thousands of computers that are all sort of checking each other's work in order to make sure that no one cheats. That's great from the perspective that it's a way to sort of get trust without knowing who anybody is or needing to rely on the law or whatever. But it's bad from the perspective that you're doing 10,000 times as much work as you need to be doing. Right? So I think you have to trade that off in and there may be applications where that's important, where all the actors aren't associated with each other and aren't clear. But I mean, sort of the origin cases, thinking of blockchain as payment systems, thinking of Bitcoin, I think payment systems work pretty well. We have Venmo, we have PayPal, so on. We have a lot of different options. They're typically faster, much higher capacity, and cheaper than things like Bitcoin, certainly in the context of a place like the United States with a developed financial infrastructure and a developed legal system around finance. And there it's less clear to me that there's advantages to moving to decentralized systems.
I completely agree with you, right? I think I'm not going to stop using credit cards anytime soon. Right. I think there are places where you want to solve a problem, and that's where you bring in blockchain, in my view. By the way, a fancy database, perfectly fine by me. If my food is safer, I'm quite happy.
Yeah. And the other thing is, I actually, from working within these enterprises, there isn't trust because there are actually tens of thousands of people that don't know each other that collaborate. And so while I generally agree with your macro issue, that those costs that you're talking about become really big in open sort of public blockchains, in private permissioned and enterprise blockchains, there are literally tens of thousands of people that don't know each other, that have to interact and are required to interact, and in fact have legal liabilities because the trust is not there. So in fact, the costs become smaller. And the compute costs that you're talking about are much less relevant relative to the liability costs, the transactional cost of capital moving through smart contracts. Those things we see as becoming larger and larger. And because of Moore's law, the compute cost and the cost of bits and bytes is actually going smaller and smaller. So again, not disagreeing with your public blockchain premise, But for private blockchains, there is a big trust issue. And large enterprises are grappling with this because when they're asked by public blockchains or consortium blockchains like the Walmart blockchain initiative that was announced with collaboration with IBM, enterprises are not able to. I mean, they'll do a little pilot just to show they're playing along, but they don't have their own data in a single version of truth. So how are they going to contribute to a consortium blockchain? So it sort of begins from an enterprise outward rather than from top down.
Joe, I think you need to respond because if I heard that correctly, Ciamac said your life's work is a fraud.
So the architecture of blockchain systems have a long way to go. They are definitely in these early iterations, they're definitely far over secured. And it is the case that there are many different kinds of applications. Some of them should map onto centralized structures. Some of them should map onto more decentralized structures. Some should map onto radically decentralized structures. One could create a society where you have government controlling all these systems and severe punishments for behaving outside of those systems. I'm not sure that we want to live in a totalitarian regime. So there are other mechanisms that you can use. You can have lots of different actors, whether it's in an industry, in a sector, along a value chain like a supply chain, that all share the same infrastructure, that can all trust the infrastructure. It's hard to create a consortium these days because you've got to get a bunch of businesses into a room. You've got to figure out intellectual property issues. You have to decide where the software sits, who owns the machines, et cetera. With this technology, you can start a proto-consortium with two counterparties and one use case, and you can add members and remove members based on certain criteria. So it's a much better way to start building collaborative infrastructure. On Ethereum, right from the start, with the public blockchain, we anticipated, and we weren't coming out of the Bitcoin space where we were crypto anarchists focused on doing secret transactions amongst one another. We were a group of makers and builders, software developers, building a new kind of decentralized application platform. And so we anticipated that 99.99% of the transactions on that network would be from disclosed identities with rich reputation. We built something called UPort, a self-sovereign identity system, so that we can identify people and organizations and devices. And so in that infrastructure where you have identified people, organizations, and things, where you have automatically enforcing agreements, we built a system called Open Law that we're starting to use, and that music platform that I described is using it. Open Law is a platform for establishing hybrid, legally enforceable agreements on the blockchain. Some of your agreements are in the form of prose clauses, but some of them can be programs on the blockchain. You can escrow money into those clauses. You can send data into those clauses. You can have some clauses act automatically when conditions are met. And so instead of a world where we have this subjective foundation of trust or coercive foundation of trust, we can have a world in which we have shared mathematically derived trust, and we can have agreements that can facilitate infrastructure. And these agreements can be live rather than pieces of paper that you file away in a folder somewhere and call your lawyer about when the counterparty isn't fulfilling that agreement.
I want to ask, I'm going to move to audience questions. You guys are going to have to trust me that there's 713 of them and they're really good. So let's move away from trust for a minute, though this is a related question from Michael Mazier. What framework can we use to determine if a blockchain adds value to a particular business case? So who wants to take a crack at that?
Well, I can take it.
Do it.
Yeah, so again, drawing from our own experience, we encourage our customers, we have an option for the customers through our platform to write or not write certain transactions that are done on our system to a, what we call sort of channels that they share within workflows. So every different workflow, whether it's a harvesting workflow or an irrigation workflow or a transportation workflow or some different workflows have their own channels, and they have a choice to write or not write. And the value use case is, can you run analytics on top of that shared database, essentially, which is what that is, and extract where your revenue is leaking, where your profit is leaking. And often that becomes where they say, oh, now I see why it pays for me to just check that box and start writing it to the blockchain, because my entire channel is now doing that, and I can actually mine that data privately, even though that ledger is publicly available to everybody, but I can mine that privately for myself later for my own private use. And that's a different use case than another person who has the same data and they're mining it for something else. And not all the data is mineable because it's all permissioned. So some of it is encrypted, so you can't mine it. Others is public within the channel, so you can mine it. And one of our customers is 10, 15% savings on a particular input that they use for their management of a particular asset. And that's big impact to the bottom line.
Yeah, I can express it pretty simply, I think. If you have a set of actors who compete with one another or interact with one another in different ways in an ecosystem, in a niche, and they want to collaborate with one another, they can more fluidly collaborate with one another in this shared, collaborative, trustworthy system. You might argue that let's say an anchor actor like a Walmart could stand up a server and force everybody in their ecosystem to use that system. But then there might be a regulator or some other actor that doesn't want to trust Walmart's server situation. So that sort of infrastructure puts everybody essentially on a fairer footing.
Yeah.
I want to ask another question from the audience, which is, a lot of the conversation about blockchain has been about cryptocurrencies, starting with Bitcoin. And in a way, that's good, right? Because it got all this attention. People started working on it. It's how a lot of us learned about blockchain, was by trying to understand Bitcoin. On the other hand, Bitcoin was basically used to buy weed for the first couple of years, and now it's used for currency speculation. And by far, the most annoying people on Twitter are the ones talking about Bitcoin's prices. So it also kind of detracts from actually trying to figure out how blockchain will work. So is it a curse or a blessing that currencies are the first big use of blockchain?
So currencies, I think it was a profound invention, Bitcoin. It was really three things that were invented. It was the blockchain next generation database system. It was that value token, the money, the payment system. It was crypto economics that married the first two and incentivized sets of actors to share their resources, validate transactions, and secure a network like this. Crypto, or Bitcoin, is a cryptocurrency. It's the first aspect, the first element of what could be considered an adjacent financial industry infrastructure, and there's so much more that's being built on Ethereum and other networks. But Ether was not defined as a cryptocurrency. We defined it as a crypto fuel because on this shared world computer resource, you have to pay tiny slices of value to run the programs, to store the data. And so Ether was really the first crypto commodity. There are other crypto commodities for storage, for bandwidth, for high throughput compute. And so we're building an adjacent data, digital, financial infrastructure. And the money element is an important one. We're starting to see derivatives. We're starting to see cash settled futures from SIBO and CME. We announced with a group called True Digital that we're putting together an Ether index, and we're going to enable both cash settlement of Ether, which is, in my opinion, not a great thing because there are different liquidity pools and they can get out of sync pretty easily. But we're really excited to really ground things because we're putting infrastructure together to offer deliverable forwards. And so that will enable essentially hedgers in this new world to have better financial instruments.
Wired magazine mined a bunch of Bitcoin in 2007 as an experiment, and we lost it. Like we could have our whole business supported for the next decade without having to run any advertising at all, but we lost
You
the
couldn't
damn
have done it in 2007.
Or 2011.
Okay.
Ciamac, you want to answer that? Sorry.
I'll take a little bit of an opposite point of view. I mean, I think, I understand the necessity in systems like Ethereum and Bitcoin of having its own currency as a mechanism to sort of modulate transactions going to the system. But on the other hand, it's not clear to me what's wrong with the US dollar. Right? I mean, I'm perfectly happy with it. I can go to Starbucks and buy a cup of coffee. I can pay the IRS and, so on and so forth. And I think, the fact that these currencies have become an asset of speculation and taking their value and wildly fluctuating sort of day to day actually makes dealing with these things hard. And so far as I can tell, cryptocurrencies are not being used to pay for anything except for other cryptocurrencies, right? So to that sense, if we think of a currency as a mechanism to pay for things, they haven't been a success. I think there is some kind of certain school of economic philosophy around the fact that they're scarce versus the U.S. government can issue more dollars and so on. And I'm not a macroeconomist, so I don't know. But I think that sort of clouded some of the technological issues with economics. That's almost just philosophy.
Yeah, so I agree that nobody in this room needs to use Bitcoin to pay for anything. In the Western world, we have excellent, well-functioning systems. There are many countries in the world that don't have very well-functioning systems. I read a statistic a short while ago. So there are many unbanked people in the world. There are many people that live in countries that have extreme volatility in their currencies, and
Why don't they use dollars?
Some do. But in this country, there are many unbanked as well. And they're not unbanked necessarily because they can't open a bank account. They're unbanked because they're having trouble managing their bank account. They're getting dinged $35 fees every time they mess up, and they voluntarily withdraw from those kinds of relationships. You can't use US dollars to pay for anything on the Ethereum platform. You can't use US dollars to pay for decentralized storage on a bunch of different protocols. You can't use US dollars to pay for a handful of other of these protocols that provide real value to lots of different people that use them. We are moving into a world where we're going to be able to tokenize everything. It's pretty exciting. We can issue tokens that unify a project, that fund a project, that serve as consumer membership or consumer access to something, consumption of scarce resources. And having these digital, natively digital tokens is really valuable for these projects. We're moving from a world, and I think this is an extremely exciting element. We're moving from a world in which clearing and settlement in virtually all of our transactions extends from hours to days to weeks. It's because all the elements involved in those transactions, things like identity and reputation and money and certificates and agreements, all those things are realized in analog, frictional, and delay-filled forms. They're realized in pieces of paper and ink and rubber stamps and entries in a centralized database and subjective interpretation of agreements. As we move all those elements, and we at our company and other companies have done that, all of those elements are now realizable in natively digital form in registries on blockchain systems. And if you do a transaction involving those elements, you can clear and settle that transaction in the instant of the transaction. A regulator might want you to build in some delays so that they can do a few seconds of checking. But if we move into an economy in which we can shrink the delays between value creation events, just like with the power of compounding interest, we can compound value creation over time. I think that's going to be a huge driver for our economy.
Yeah, let me just sort of throw something in here, because I feel that you guys are taking sort of a black and white issue to here, and I think the reality is sort of gray. I mean, talking about blockchain, and our customers, for example, are great simplifiers of things, and we never see any customer saying, all my world is going to go on blockchain, and everything else here, the $200 million that I put on my IT infrastructure is all wasteful spending, right? That's not. So the world is actually gray. And it's sort of like talking about the self-driving car. It's a great idea. It makes a lot of sense. You're absolutely right. But there will be a transition. There will be a time where both self-driving and non-self-driving cars have to be on the road. And so there's plenty of, to your point, Ramesh, plenty of use cases in which traditional IT systems are more cost-effective, to your point, right? So I don't think it's one or the other. I just wanted to sort of make that point clear that we're very excited. I mean, we're very excited. Our customers are very excited about blockchain. But nobody's advocating at our customers, or we to our customers, that this is sort of the thing now. And whatever you were doing before, just throw it away, right? Eventually, efficiencies have to improve. And so, and I think nobody would argue with that. Even, you're actually making that argument that traditional technologies would improve efficiencies. So it's a gray world.
But can I push on that analogy with the self-driving cars? Because my sense of self-driving cars is they'll come slowly. There'll be human cars, there'll be self-driving cars. And then they're all going to be self-driving because they're going to be so much better. Is that what's going to happen with blockchain? Or is it going to, we're always going to have a world of yes,
there's still people using fax machines. I mean,
but there are like 4 of them.
I mean, really, they are.
So
we have customers that use fax machines, and they
use fax machines to put in their blockchain orders. That is an awesome customer.
There are people who use technology which we think doesn't even exist anymore. There are people writing handwritten notes at billion-dollar companies, and keep the workforce, the average workforce in food and agriculture, is like 60+ years old. And so they're not using many of these technologies, which we think are like sort of, yeah, of course you would do that, right? Like my son was telling me the other day, I was dropping him off to, his water polo practice, and I said, well, punch in this address, and I'll take you to this high school that I have to drop him off. And he says, Dad, you don't punch in anything, you just talk to things now.
Yes.
So I mean, things just evolve, and I think that blockchain will be, I think, one of those key elements, as will AI. I mean, I don't think it's one or the other. These are all amazingly useful technologies that can make all of our lives more efficient and better, and have the capacity to. And for example, is it a curse? There will be some, co-opting for doing something that maybe not so good for society. I mean, the internet has plenty of those things. Pick your vice. It's available on the internet. So I think that there will be those things, but generally speaking, efficiency has to improve if we're going to feed the world.
So I think it is a curse, and I'll explain why.
But you think blockchain is a curse?
No, cryptocurrency is a curse. I'll tell you why.
Okay.
I do agree with Joe. It is truly an innovation. Cryptocurrency, in my view, is a true innovation because when anonymous participants have to come together, you need the right economic incentives. I really think it's a fantastic piece of innovation. That being said, day to day in terms of what I do, right? Talk to customers about business problems, multi-parties interacting. The kind of things you talk about are things like, how do you create a minimum viable ecosystem to make everybody start working together? What is the business model? What is the governance on the data around the business model? These are all questions that are critical, important, you need to solve in order to build solutions like food trust or global trade digitization or what have you. In the midst of it, a lot of times, I get pulled into this rat hole of cryptocurrency discussions. In that sense, it is a noise.
None of our customers use
calling my panel a rat
anything
hole?
cryptocurrency based with blockchain. They don't even know what that is. They don't want to hear about it. Nobody. So it's totally sort of separate thing. I just want everybody to know that.
So I think there are places for both is the right way to think about it. There is good use cases for public cryptocurrency-based blockchains. There are enterprise ones. It's just that the amount of attention cryptocurrency is getting is where my frustration is because it takes away from important discussions that we need to have.
That's right.
That sounds right. All right, so we have 6 minutes left. Another question, this one from Bettina Buss, which is something we've touched on earlier, but is a great question. Scalability. What are the issues and how can these be solved? You talked about Moore's Law, resolving things. That is the process by which processors get way faster. Clearly, storage will be much better. Is that just going to resolve all the blockchain problems? I'm guessing we're going to have a no at the end and maybe a yes in the middle.
Jump in.
Sure, you want to go first?
So we have this database technology that enables us to process hundreds of thousands of transactions per second, millions in some cases, and for these blockchain systems, we've thrown that all away and gone back to, say, 3 transactions on Bitcoin and 25 transactions per second on Ethereum. And we've done that because we bought trust. We bought a foundation layer that we can then build layers and layers of functionality on top of and be really quite certain that we can collaborate trustfully no matter who's on the network. Now we have to rebuild trust. Bitcoin has its own roadmap. Ethereum has had a roadmap towards scalability right from the start. Currently, blockchain systems are still immature. For a full node, every one of the nodes has to store all the data and process all the transactions, and that's a generation 1 system. We're moving in Ethereum to situations where only an appropriate number of nodes will have to validate transactions and secure those transactions. And you can secure the entire network that way. So there are mechanisms called state channels, called plasma networks, called side chains, called sharding that will take us to very efficient systems that effectively have infinite scalability. And what I mean by that is currently if you add a new computer to the Ethereum network, you get a slightly more secure network, but because of the communication overhead, you slightly reduce the transactional throughput per second. But if you can shard the network, or if you can add side chains that do some independent work and sync up in various different ways, or validate transactions, or move tokens across the networks, you can then add sets of computers, sets of storage onto these systems, and every one of those new functional units adds a whole bunch more transaction throughput.
So
this year we'll see a bunch of applications making use of 2 of those mechanisms. One is called state channels, one's called plasma, and in a private permission context, we can take the Ethereum technology, we do this all the time with governments and enterprises, and we can run very high throughput on that. You can relax assumptions, you can make optimizations, you can use those in enterprise systems. We will see similar systems like that linked into public Ethereum that will be able to handle quite high throughput in some applications this year.
Ciamac, do you want to respond on that, scalability?
Yeah, so I think I agree with a lot of what Joe is saying.
We always agree with each other.
So from the perspective of private blockchains, I don't think there are really scalability issues. I think probably everyone agrees with that. From the perspective of public blockchains, again, it's coming from the fact that security is coming from everyone is replicating all this work. And I look forward to people like Joe innovating and coming up with better methods in order to mitigate that. But I think that's on the technological side. I think there's a second issue, which is kind of an economic issue, which is in these public blockchain systems, who pays for it, right? Bitcoin costs, I don't know, $10 to $50 million a day, depending on how congested it is to run. Who's paying all that money? Well, the long run vision for, I think, both Bitcoin and Ethereum, correct me if I'm wrong, is that the users will pay. You'll pay transaction fees. You'll choose what you want to pay, and why would you pay anything? Why would someone pay more than someone else? Well, you do that to prioritize your transactions. You do that to get to the sort of head of the line. Well, when you start sort of, both building models and looking at real world data and thinking about this, the only reason someone is going to pay to cut to the front of the line is if there's a big line, right? So the way that these systems will be economically self-sustaining is if they're congested and slow, because otherwise, in the current kind of economic model based on transaction fees, no one will pay to cut a line that doesn't exist.
So that's definitely not true.
All right, we got 1 minute, Joe.
Sure. So on the internet, there are lots of resources. Somebody has to pay for them. On Ethereum, we're very soon going to enable the receiver of a transaction to be able to pay. So if you're standing up a business, you can handle all the costs for your consumers.
But why would you do that? You do that to have them come faster.
Why does Facebook do that? Why does
Google
do that? Because they've got a business
speed,
model
right?
that they think is, sorry?
You do it for
But
speed.
You're talking about we should take this offline probably, because you're talking about a very narrow situation with respect to Bitcoin. I'm talking about building applications on a decentralized application platform, having business models that support the costs and bearing the costs, the transaction costs of the consumer accessing your services. And so these systems are going to be decentralized. There'll be lots of different actors providing resources. There'll be much more efficient than a cloud infrastructure, for instance.
All right, Ciamac, wrap this up. Explain everything. When you're done with your 30 seconds, everybody will understand everything about blockchain. Or else we failed. Bring it.
Well, I was just going to make a trite comment, but now I have the weight of your request. That basically the scale will happen because it has to. And the reason it has to is because of efficiency.
That's right.
It's actually not because of blockchain. That's an enabling technology. All technologies, plural, have to enable efficiency, transparency, and change this sort of erosion of trust that I think is a big part of our society. And I think that is why it has to scale. It will. The costs will come down. There are inefficiencies in cost structures built today that will disappear and be replaced with other costs, but overall the costs will collapse because I think that is what the consumers will demand at the end of the day.
All right, the reason trust is eroding in society is because panels run long. That will not happen here. We are done. Thank you, Ciamac. Thank you, Joe. Thank you, Ciamac. Thank you, Ramesh.